So I taken it as A.
A. So same as Ayush. So actual the answer to this is B, not A. Smera, could you tell us your logic? How did you solve this?
Yes, sir. So, I just equated both the sides. So, it will be 3V into P as equal to V into 3P.
Why did you equate?
Sir, because both are like ideal gases, right, of the same temperature and
So the temperature is
molecules and
constant, yes. So can we equate P into V in that case? Say because the ideal gas equation is PV is equal to nRT. If your temperature is constant, R is anyways constant, but still this N is still there.
yes, sir.
So we cannot equate P and V for both the sides.
You would have to add both the equations together.
Okay, Vaibhav, tell me your approach. How did you do this?
Yeah, so you take the first part as P into 3V over nRT, and you can take the other one as 3P into V,
Okay.
and then you add the both, and you know that the volume has to be 4V, the total volume.
Mm-hmm.
So you get 4P is equal to 6PV, and then you divide it by 4, and you need to get 3P by 2.
Okay. Okay.
And then and then the change in pressure would be like the initial pressure, like you would deduct that from 3P over 2, and you get P over 2.
P over 2. All right. Samir, what was your approach?
Yes, I had the same approach as well.
Okay. But Vaibhav, I'm not sure whether we can add. So you said, could you tell me the first step of your approach? You were adding something.
Yeah, so you would add, so basically you would add 3PV over R2 plus 3P plus what do you call it, plus 3PV over RT, and then um,
Okay. So
you
what am I equating this to?
you equate it to 4V because that's the total volume. And so basically you can
Wait, wait.
no, sorry,
Just a second. Just a second. So if I
it'll
take
be pressure, it'll be the final pressure into 4V over RT.
no, no. Oh, okay. So just right hand side. Please tell me the value again on the right hand side.
Yes, so the right hand side would be the new pressure,
Okay. Let's
whatever
say
the new
P
pressure is.
dash.
Yeah, P dash, and you would multiply that by 4V over RT,
Perfect.
and you
Yes.
can find it.
Yes. So on solving this, you will get P dash as 3P by 2. And since
Yes.
we are
So, but
supposed,
is it mentioned that in both the containers the number of moles are the same?
no, not at all. So that is why I was wanted you to explain.
So, but technically,
But
if you just simply use PV is equal to nRT, both of them have the same value of 3 PV, so we can assume that they have the same moles.
Mm, yes, in this case you can. Correct.
Yeah,
If the
because
temperature,
temperature is also constant and is always a constant. So,
yes, yes. So we can do that. But anyways, let's say if you do not make that assumption. So what Vaibhav has just said, let me reiterate with the with a modification, small modification. So PV is equal to nRT. So if I take the gas in container Q, so the pressure is P and the volume is 3V. Now let's say the number of moles of this gas is Q and we take R and T. So this is the first equation, and if I consider the R container, pressure is 3P, volume is V. In this case, let's say the number of moles of the gas is nR and you have then R into T. And the last equation will be the total pressure will be new pressure P dash multiplied by the total volume, which will be 4V. That will be equal to the sum of the two gases, the two moles, and R into T. So basically what Vaibhav was telling here is nothing but this same thing over here. So what he has done is, if you observe P into 3V divided by RT, this is your NQ. This particular bracket is NQ. Now if I check 3PV by RT, this is your NR. and P dash into 4V by RT, this is your NQ plus NR, which comes from the last equation, the equation number 3rd. So is everyone getting this? What is being done here? So even if you do not assume that the number of moles is constant, we can take that as some variable and then proceed. But anyways, as Saumil just said, since the left hand side 3PV is a constant, on the right hand side it has to be a constant. So in this case, the number of moles of Q and R both are the same. Anyways, whatever method you use, the answer should remain the same. The change in the pressure comes out to be P by 2. Sheldon, did you understand the method?
Yes, sir, somewhat I got it.
Okay, so you will have to revise this and let me know later. Ayush, what about you? Got the method?
So I still don't understand why NQ equals NR.
Okay, so see, PV is equal to nRT is the ideal gas equation. So if I consider the container Q, so the pressure is P, and what is the volume, Ayush, in Q's case?
In the case of Q is 3V.
Yes, so the left hand side becomes 3PV, isn't it?
Yeah.
Now in case of R, tell me what will be the left hand side, the product of pressure and volume.
It'll be V there. So
3P multiplied by
3P V by RT.
So even in that case, the left hand side is the same. So for R you have 3P times V, and for the container Q you have P times 3V. So can you observe that the left hand side is the same?
Yeah, understood.
Right.
Okay.
Okay, great. So let's move on to the next question. Question number 9. This is not very difficult. Smira, what's your answer to this?
Sir, B.
Okay. Saumil?
So I actually got A.
Okay. Vaibhav?
It's B, right? So
All right. Ayush?
So same as Mela.
So
B.
B. Okay. Sheldon, did you solve this?
Yes, I did, and I gotten it as B.
B. Okay. In fact, B is the correct answer. Saumil, you have to check how did you get A. So can you tell me your approach, Saumil, first?
So we had learned a formula in school which said pressure is equal to 1 by 3 rho into c square, where c is the mean square velocity.
Just a
So
second. Let
that
me write down the formula. P is equal to 1 by 3 times
1/3 rho c square, where c square is the mean square velocity.
Okay.
So like this equation, it directly says that if that pressure and c square are directly proportional. So I just thought of this in the mind and circled
Okay.
A.
So first of all, we cannot deduce from this that pressure and the mean square speed are directly proportional, because there is one more variable here, the density, which is mass by volume. Now although the mass is constant, but the volume may not remain constant, isn't it?
Yeah.
So we cannot deduce that the pressure increases or decreases depending on the C. There is a variable V, so unless you incorporate that in your deductions, we cannot use this formula. Smera, could you tell me how did you get B?
So like I just use theory in this.
Okay, so could you elaborate? What theory?
Yes, sir. Like so, pressure is like the force exerted like on the
Yes.
like the walls of the gases,
Correct,
right?
yes.
So like it is the number of like striking.
Yes, good. So the perfect. So the number striking the container with each second, this is the actual definition of pressure. So this is just theory. Saumil, is it clear? Or do you have any doubt?
So yeah, it makes sense. Like if the pressure is decreasing, then the striking of the molecules every second will also reduce.
Yes, true. So we can use even the ideal gas equation for this. So PV is equal to nRT. So in this case the temperature is constant, R is anyways constant, and since the mass is fixed, so N is also constant, which means P is inversely proportional to volume. Now since the pressure is getting reduced, which means the volume will increase. Pressure reducing, volume
Yeah.
is increasing. Now volume is nothing but the area multiplied by the length. So if you have a cylinder, let's say, which is fitted with a piston, so increase in the volume means the piston is going up, right? And the number of molecules inside the container still remains the same. So if I check the number of molecules striking the container each second, since the area has increased, the surface area, so the number of molecules striking the container, that will fall, isn't it?
Yeah. Got it.
Okay, great. Let's move on. So okay, let's discuss this as the last question for today's class. Rest we'll do in the next. Ayush, what's your answer to this? 10th.
So I wrote C.
Okay, good. So that is the correct answer. Did everyone get this answer?
Yes, sir.
Yes, sir.
Vaibhav?
Yes, sir.
Okay, Sheldon, did you get C?
Actually, so I got very confused for this one. I had written it as A, but then I cut that off and I wrote it as B.
Okay, let me tell you the approach. So this is not very difficult. So in the numerator you have specific heat capacity of copper. So if you use this basic formula mc delta T, this has the C as the specific heat, and the other formula which we take when the phases are changed. So Q is equal to M times L, where L stands for the latent heat, which is your denominator. So basically what you need to find is C divided by L in unit terms. So from the first equation I can write my C as Q divided by M delta T, and from the second equation I can write my L as Q divided by M. Now if I divide these two expressions, so we will get C by L, so the Q by M will get cancelled out, so you will have 1 by delta T, and delta T's unit is Kelvin, so this can be written as K to the power of -1, which is option B.
Oh,
So
already got it.
this
So
is the way to do it. So please write down the solution.
my solution is actually very close to this, but I just stopped at Kelvin inside.
Okay, chalo, no problem. So this is the end of today's class. So let's do one thing. I'm writing down the answer key for the rest of the questions. So please write this answer key first, and you can then later on cross check. So 11 is so 11 to 20, this is the answer key. So please write this down. And let me know when you finish.